front page looks more like this. So what I'm going to be doing today is I want to show you what we call the process of factoring a quadratic, a trinomial. And basically what we're going to be doing is undoing the multiplication that we worked on and actually took a recent quiz on. So let me show you basically what that means, what that entails, and then I'm going to move you quickly through the process of factoring, which you're going to be doing for homework tonight, and or tonight or tomorrow night. So first things first, I just want to go over. Let me just find a little piece of blank paper here. I'll just go ahead and use this area here, and you do not need to write anything right now, but if you could just follow along with what I'm talking about, you may have a better understanding of what I'm going to be talking about in a moment. But if you remember, we multiplied numbers like x plus 2 times x plus 3. And one of the processes we used is basically to distribute twice. So we're going to distribute the x over these two numbers of the binomial. Then we'll distribute the 2 over these two values in the binomial. So you should already be familiar with this. The double distribution is often referred to as FOIL, where you multiply the first terms first. X times x are the two first terms of the binomial, getting x squared. And then the O is the outside, the x times the 3, so plus 3x. And then now we're going to the 2, and we multiply it by the x. The two inside terms gives us 2x. And then last is the 2 times the 3 for the positive 6. So that's FOIL. And we often have to combine the O and the I to get, because they're like terms, and so we get 5x plus 6. Probably worth noting that this is in standard form because we're going from high degree of 2, 1 degree, and then 0 degrees. So keeping it in standard form. So what we're going to be learning today, though, is how to go in the opposite direction. Question is, what happens if I get the x squared plus 5x plus 6? How do I go back to the factors that created it to begin with? And so basically the idea is like, how do I go back to where I started from? Well, one of the ways that we're going to do this is we're going to recognize the relationship between the 5 and the 6 and the two numbers that we started with, the 3 and the 2. So we got x plus 2 and the x plus 3. Well, you may notice that the 5 is the sum of the 2 and the 3. And the 6, that last number here, comes from multiplication of the 2 and the 3. So if you can hold on to that relationship, basically the idea is we're looking for two numbers that add up to 5 and multiply to 6. So going backward, I go, okay, well, I know my first terms of FOIL are going to be the x and the x. And now what I want to do is I want to fill these two areas with two numbers that add up to positive 5 and multiply to positive 6. Well, the answers are positive 2 and positive 3. Does it matter what order I put them in? The answer is absolutely not. You could have put it as x plus 3 times x plus 2, means the exact same thing. So that's what we're going to be doing today. It's going from here to here. And for our purposes for this first section, for now, as long as there is as long as the coefficient or the lead coefficient is 1, which we typically don't write, this is how we're going to be doing the factoring. So I want to erase this and go ahead and get started with our work. Hopefully that made some sense. If not, maybe it'll make more sense as we go through this. So let me erase this and we'll go back to what I'm going to have you do is I would like you to go to page 2. And on page 2, we'll we'll start with exercise 1 and see if you can't pick up on it. If you pick up on this first time, you're going to find that it's really pretty easy. So if it doesn't seem that way, you may be overlooking at it. So looking at it too closely. So anyway, let's move to. Hello class, I hope you got the note to bring headphones or earbuds. If you do not have either, you can ask the substitute to lend you a headphone set from my bottom left drawer of my desk, and hopefully they will not have a problem with that. In addition, the substitute should have handed out the sheet that you're looking at. Yours will not be in color, but you're going to be following along with it. I move to the second page, and a couple pieces of terminology that they use here is in terms of the factors themselves, is they use the kind of a generic term of, instead of the 3 and the 2 that I use, the more generic version is just going to be this, they're going to call P and Q, the two numbers that add up to the middle term and multiply to the last term. So unfortunately, they make this look a lot more confusing than it should be. A couple other things that they're going to use for terminology, just so you have them, is the number before the X term, and they're going to call B. So B is the number that they add up to, and C is the number that that we multiply to get. So maybe when we do a couple more, it's going to make a little bit more sense. So I don't want to spend too much time with this core concept because the way they write it, I think, can sound more confusing than it actually is. So let's go ahead and go to the first example. And in the first example, what I want you to do is I'm just going to factor it for you. And again, factoring is the same thing as unmultiplying. We want to get back to the two binomials that produce this. And so on this one, what we're going to be looking for, again, is this is our value for B, and this is our value called C, and we'll use that because we'll return to it later on. So if B is equal to 10 and C is equal to 16, what we're looking at is two numbers that multiply to be 16 and add up to 10. Well, think of the different ways that we can multiply to get 16. I got 1 and 16. I've got 2 and 8. I also have 4 and 4. Now, looking at these three ways of multiplying to get 16, do any of them add up to 10? Well, yes, the 4 and the 2 and the 8. So I'm going to use that 2 and the 8 to create the new the factors that created this. So I'm going to put two parentheses down for my binomials. I'll put an x and an x first because those first terms multiply to become that x squared. And then I'm going to put the 2 plus 2 and then the plus 8 here. And that's it. Now you might wonder, oh, does that really work? Well, let's go ahead and multiply it. If I have x plus 2 times x plus 8, let's go ahead and multiply the first terms. You got x squared. Outside terms, x times 8 is plus 8x. Inside terms, 2x. And then the last terms, 8 times 2 is 16. If I collect the middle terms, I get x squared. 8x plus 2x is 10x plus 16. So there it is. So clearly those were the binomials that made it up. So the answer to the question, the answer to the problem, factor x squared plus 10x plus 16, your factors are this, x plus 2 and x plus 8. So this is the process that you're going to be undergoing for the homework tonight. So let's go ahead and we can really quickly review what we just did. This is the book version of the solution that you're seeing right now. We just did it the Mr. Scheidegger way, but to be more detailed, if you look at this, it says, it's going, notice that B is equal to 10 and C is equal to 16. So what they did is down here, they wrote all the different ways that you can multiply to get 16. And then they added them up, and they noted, if you add up the 1 and the 16, you get 17, the 2 and the 8, you get 10, and the 4 and the 4, you get 8. Well, which one are we looking for? Well, we're looking for two numbers that also add up to the 10, the B value. So there you go. So let's go ahead and what do I have? Do I have any more on this page? I don't think I do. So let's go ahead to let's go to the next page. And here we have two opportunities for you to practice this. And and what I'm going to do is I'm going to ask you in a minute to go ahead and pause this video so that you can try a couple of these on your own. But I'm going to start you with number 1. And remember again, okay, this is my B value. My B value is 7. We're going to call that B for now. We're going to call this C for now. And we're looking for two numbers that multiply to 6 and add to 7. And the easiest way to try to figure that out is to think of all the ways that we can multiply to get 6. So on the side, we can write 6 times 1, 2 times 3. It looks like that's it. Now, you need to answer the question, which of those two factor setups is going to add to 7. Hopefully that's obvious. I'm going to put an X here and put an X here, and then you're going to put those two numbers in there. I'm going to let you pause this now and let you put those two numbers in, and I guess give you the choice of which numbers to put in there. Hopefully you'll make the right choice. And if you get that right, once you stop the pause, you'll be able to get my explanation. But why don't you pause right now and see if you can't finish that on your own. Take a minute and do that. Okay, well, I am hopeful that you chose the right numbers here, plus 6 and plus 1. Again, doesn't matter what order. On the next one, we're going to go ahead. We can just put our x's there because we know that the first term, the product of the first terms is going to be the f of FOIL. It's going to be x times x is x squared. Now we need to figure out which numbers that multiply to 8 and also add up to 9. Well, let's go ahead and put some factors down. 1 times 8 is 8. 2 times 4 is 8. That's pretty much it. Which one of these two adds up to 9? Well, it looks like 1 and 8. So plus 1 plus 8. Done. Okay, so that's the easiest factoring that we have. Example 2 shows us one step that's will outline the next step up. And in the next step up, we'll notice that the B value is negative, which means that the two numbers that we have to multiply to get the 12 must both be negative. Why? Because to get a positive 12, we either have to multiply two positives or two negatives. And so if we're looking for two numbers that multiply to 12 but add up to negative 8, then we need to be looking at two negative numbers. Okay, but it's pretty much the same problem. Let's go ahead and take a look at the ways that we can multiply to get positive 12, and we could go negative 1 and negative 12, negative 2 and negative 6, negative 3, negative 4, and I think that's about all we can do. So question is, which of those two multiply to positive 12? Well, all of them do. But which of the two also add up to negative 8? Well, there it is. And right in the middle there, you see the negative 2 and the negative 6. Those will be the two numbers that we're going to use in our factors. So we're going to put our parentheses down again, put an x at the beginning, and the two numbers, minus 2, minus 6. And again, if you multiply those out using FOIL, you'll get x squared minus 8x plus 12, just like we would hope to. All right. Again, this is really no different than what you kind of did in middle school when you learned first how to multiply 2 times 3 to get 6. And then later on you said, okay, well, what did I do to get the 6? Well, I broke it up into 2 and the 3. We used the factor tree to do that. This is just a little bit more complicated version of the exact same idea. So let's keep going. Again, the more formal solution is given to you here, where they're giving you b is -8 and c is 12, two numbers that multiply to positive 12 but add up to -8, and they give you all your all the possibilities down here. Only the middle possibility is the right one, right? So mine was a little bit more brief, but this is a more blown up version of it. It makes more sense for you. Then then use it, please. So let's go to the example 3, which is the last version of what you're going to be doing for homework tonight. So next page. If you come here, now this is the most complicated version of this. It's still relatively simple, but you'll notice that in this case, the C value is -21. A negative final value, a negative C value, means that one number has to be positive and the other value has to be negative. And so they still need to add up, though, to +4. So what are the different ways that we can multiply to get -21? Now, in the future, I just want to tell you that as you do more and more of these, you're going to be able to write less and less. So these little charts here that you're seeing right now are eventually not going to be used by you very much, but they're still very helpful. Let's look at all the different ways I can multiply to get -21. If you see that, -21 and 1, and then -1 and +21, right? Because both of those add up to the negative, both of those multiply to -21. Also, -7 and 3 and -3 and +7. Notice that only the -3, +7 add up to the 4. An interesting thing when you have a negative C value is that it's basically the difference between the two numbers that we're dealing with. So once you see the 3 and the 7, you go, if you can recognize that the difference between them is 4, that's going to help you narrow down your choices. So the -3 and the 7 is going to be, is going to be what you're going to, are going to be the factors that you're going to be using, the terms you're going to be using. So you got x -3 and then the x plus 7. Some people notice that if the middle term is a positive, then you probably want to choose the larger number to be the positive value if you have a situation like this. Okay, so now what I want to do is we have six practice problems that we have that I need you to be able to do before you start going off on the homework. And then, but I also have a problem on the last page that's a little complicated, but just gives you a sense for the power of this factoring. So first off, factor this polynomial. Notice that in this case we have a +3, which means both numbers have to be the same sign. And so let me go ahead and put my factors here. My two parentheses there. I got W here and a W here. Now I'm looking for two numbers that multiply to 3, +3, but add up to a -4. And if you remember, that means that both numbers need to be negative. Well, there's not too many ways that we can multiply to get 3 outside of -1 and -3. And thankfully, those two numbers work. So -1, -3. Now I'm going to pause right now, and I'm going to ask you to see if you can't do number 4. So just go ahead and pause this video for the moment, and when you think you've got the answer, then turn it back on. Okay, welcome back. Then hopefully that didn't take you too long, but you're going to put an N here for the F of FOIL, the first terms. And again, the last terms would produce the 35. multiplying the last ones, what two numbers multiply to positive 35 but add up to negative 12? That seems like a tricky one, but of course we can, off to the side, I think it's always helpful if you get stuck, is to try to write down all the different ways to get 35. Thankfully, there's only two. So 1 and 35, and you got 5 and 7. Well, interestingly, the 5 and the 7 add up to the 12, but we're going to need to make them both negative. If we don't make them negative, they don't add up to the negative 12. So negative 5, negative 7. All right, now I'm going to challenge you to pause this and see if you can't do number 5 and number 6 on your own. So pause this video, and when you have 5 and 6, turn the video back on and we can check your answers. Okay, so here are the answers to 5 and 6. 5 wasn't too bad. It's two numbers that multiply to positive 24 and add up to negative 14. Again, if you get stuck, you can always just write the factors. Once you start writing these, you're going to see that the answer when the answer finally pops up, it'll make sense to you. But I already passed the correct answers to 2 and the 12. So again, whenever you get stuck, you're not sure what two numbers you're going to be dealing with, just write all the factors of the last number. Negative 15. How do we get to negative 15? We can multiply by 1, 15, or else 3 and 5. Now, because it's negative 15, we know that one of the signs is negative and one of them is going to be positive. So basically, we're looking for two numbers that have a difference of 2. And that would be the 3 and the 5. Why did I pick positive 5? Well, because positive 5 and negative 3 give me my positive 2x in the middle. So challenge yourself for the next two. Pause, and when you're done, when you think you've got the answers, go ahead and start the video back again. Okay, so see how you did. The last two, 7 and 8, were both, C is negative on both of them, so the signs, the terms will be opposite in sign. And if you do the factors of 30, you will see that if the signs are if you got a negative C value, that means that you're looking for a difference that's going to be the 13. So which of these numbers has a if you subtract one from the other, gives us a negative 13, gives us a 13. Well, that would be the 2 and the 15. Why did I pick positive 15? Because the middle term has to add up to positive 13, and plus 15 minus 2 is that. Number 8, 42. If you get stuck, you could write down all the different ways of multiplying for 42. For most of us, I think we remember that 7 times 6 is 42. Again, because it's a negative 42, one's positive as one's negative. Why did I choose a negative 7 in this case? Well, the negative 7 is because I need to have these two numbers add up to negative 1v. And negative 7 plus 6 is that combination. All right, so now what we're going to do is we're going to move to the last piece of this talk. I want you to kind of at least get a sense for the types of problems that we can now solve. This one would be virtually impossible in many respects, but now you're able to approach it. Let me show you how this one works. It's kind of a goofy question. Anyway, a farmer plants a rectangular pumpkin patch in the northeast corner of the square plot of land. The area of the pumpkin patch is 60 square meters. What is the area of the square plot of land? So they want to know what the area of this huge square is. Of course, in the real world, I guess you just go out and measure it and apply the formula, length times width. Well, this is a square, and so it's S meters times S meters. That's not a 5. And so the question is, how can I find out what S is? Well, interestingly, and this is going to be something you're going to be doing more of in math. If this side here is 40 meters, and the whole side is S, this little chunk of pumpkin patch, which is here, the 600 square meter pumpkin patch, is going to be the whole side, s, minus that part 40. Similarly, the length of this is going to be s, the whole length of this thing, minus that 30 feet that's not the pumpkin patch. So if we look at this, if we look at the factors as being the area, we can say now that s minus 40 times the length s minus 30, doesn't matter what order we're in, equals 600. Now you look at that and you go, whoa, that may not be possible to solve, but we can solve it. And let me show you how we're going to do that. We're going to FOIL this first. So s times s is s squared. And then we go to the outside terms. S times minus 30 is minus 30s. Now we go to the negative 40. Inside, negative 40s. 40 with a 0, s. And negative 40 times negative 30 is positive 1,200. And again, this is equal to 600. So it looks pretty complicated, but let me go ahead and simplify it. I have s squared minus 30, negative 30, negative 40 is negative 70s, plus 1,200 equals 600. Now, a very important thing is if I'm going to solve a quadratic, which this is because of that squared term on the s, I need to do it by factoring. That's the only way we know how to do this. So to factor and solve, we need to get 0 on one side of the equation. And so I'm going to do that by subtracting 600 on both sides. I get s squared minus 70s plus 600 equals 0. So that's 1,200 minus 600 is 600. And now, believe it or not, we can actually factor this. And may not become immediately apparent, but if I have a negative 10 and negative 60, that actually multiplies to positive 600, and it adds up to negative 70. Pretty crazy. But so now that I have it equal to 0, let's remember this. We go s minus 10 equals 0, and we go s minus 60 equals 0. So add 10, s equals 10, and add 60, and s equals 60. Now, oftentimes when we're doing problems, the math doesn't realize that we're actually working on real life situations. So there's a limit to what numbers I can use sometimes when I'm applying them to the situation in a problem. And so what I'm going to show you, though, is that this number here, s equals 10, really can't work. And why not? Because if you go up here, s is supposed to be the entire side of this, and it already has 30 meters here. So the whole side can't be 10 meters if there's one part if part of the side is already 30 meters long. So that is a value that doesn't work, but the 60 does. The 60 can work. And if we look at it, if we take the s equals 60 and we said 60 minus 30, we would get 30 for the length. And if we did the same thing here, 60 minus 40, we would get 20 for the width. And so if we take the width and the length, we multiply them together, well, guess what? We get our 600. So we get this, very, a pretty complicated problem, but the tools to solve it are all, are what you possess right now. Okay, so one last little thing is that you're going to see in your homework is they're going to ask you to take certain equations and solve them. And I just want to quickly note that we already know how to do that. If we can factor, we can solve. So if we have a problem like x squared plus 5x plus 6 equals 0, and the question says solve it, well, again, remember this is a quadratic because of that squared term. We can't just subtract 6 and try to divide by 5. That's not going to work. The only way that we can solve a quadratic is by factoring. So the later part of our homework assignment, they're going to ask you to factor and solve. So if I factor this, again, I'm going to put x's in the front for the firsts, x times x is the first term's x squared, and then I need two numbers that add up to that multiply to 6 and add up to 5. So again, that's going to be the two ways that we can multiply are 1 and 6 and 2 and 3. The 2 and 3 add up to the 5. So yes, we're going to have plus 2 and plus 3 equals 0. So now we rewrote the equation in factored form, and now we just do our little x plus 2 equals 0 and x plus 3 equals 0, and subtract 2, and x equals negative 2. And over here we subtract 3, and we get x equals negative 3. And so in the later part of the homework, you're going to be asked to do that. In a way, what you're doing is putting together two things: the tools of factoring, and then your older tools of solving equations when they're in factored form. So that's about all I have for you right now. I'm going to ask you to, if there's still time in the period, which I'm sure there is, I would like you to go ahead and start the homework and see if you can't get a good start on that before the end of the period, and hopefully finish it before then. So take care and have a great day, and I hope this made some sense to you. If not, please talk to your friends and see if they can help you with this too, because I would imagine some of you have possibly even seen this before. Take care.